So part one of this week's lessons is determining the floor joist spans using the Ontario Building Code. I'm going off the 2006 version, but the latest version also has the same tables. So when I'm talking about span in this case, what span is, it's a clear span between the two supports. For the total span, you would add your two bearing lengths. So for example, let's say I've got two foundation walls of a basement, one right there and one right there. So if the rectangle in blue is my beam, my span for the building code is going to be the distance from right there to right there. Another term that we'll encounter are the bearing lengths, and the bearing lengths are the distance from there to there and from there to there. So basically the bearing lengths are what your beam sits on top of, the distance that it sits on top of your foundation wall or on top of your column. Supported length is going to be another term that we'll encounter, and what supported length means in this case would be half the sum of the joist spans on both sides of the beams. So let's say we had a floor system and our beam is shown in red. Our foundation walls are on this side right here and on that side right there. So our joists are running this way like that. So what our supported length means is that half the distance here and half the distance here would be supported by this beam here. So half the support of the entire floor would be supported onto this beam. The other halves here and up here would be supported onto the foundation wall. So for example, if we had a floor system that was 20 feet wide and the distance to my beam was 10 feet, my supported length for that beam would be 5 feet from this side, 5 feet from this side. So a total of 10-foot supported length for my beam. And the supported length for this foundation wall would be 5 feet. The supported length for this foundation wall would also be 5 feet. So the tables we'll be using are tables A1 in the back of your building code. There is also table A2, which is special cases for floor joists. We're going to go with general cases for floor joists. So table A1 right here. And the first thing we're going to look at here is at the top of my building code, I've got some columns, and we're going to explain what those are. So we've got commercial designation and column 1, and what that is that indicates the type of wood. So spruce pine fir is the most common type of wood used in this area, and 99% of the times you're going to get a spruce pine fir piece of lumber. We've got grade, which represents the structural strength of the lumber, and that's determined by how many knots it has, the defects it has. Select structural will be our strongest, followed by number 1 and number 2, number 3 construction, and then standard. So if we're getting lumber from the lumber store, generally it's number 1 and number 2 grade lumber. Next we've got joist size, and that's given in millimeters because we're in Canada. All the OBC is generally done in metric. To convert that over to inches, the 38 by 89 is a 2 by 4, 38 by 140 is a 2 by 6, 38 by 184 is a 2 by 8, 38 by 235 is a 2 by 10, and 38 by 286 is a 2 by 12. Columns 4 through 12 is where we're going to determine the actual spans. So we've got options with strapping. So that's strapping underneath the joist on the bottom of the joist. With bridging, so that's the cross bridging that gets put into the joists, and with strapping and bridging, which will be our strongest. And then it's given us our joist spacing in millimeters. So 300 millimeters would be 12 inches on center, 400 would be 16 inches on center, and 600 millimeters is 24 inches on center. So our maximum span shown here is given in meters. So what that's telling us is if I had a 38 by 184 select structural right there, which is a 2 by 8, and I had my joist spacing at 300 millimeters, which is 1 foot or 12 inches, with bridging, that I could span 3.94 meters. So I could span 3.94 meters with a 2 by 8 if my joist spacing is 12 inches on center and I'm using bridging. So coming up here in our next slide, I'm going to show you how to do that. Actually, first what we'll do is we'll take a look at the notes on table 1 at the bottom. So the first note says that spans apply only where the floors serve residential areas as described in table 4.1.5.3, or the uniformly distributed live load on the floor does not exceed that specified for the residential areas described in table 4.1.5.3. So you'll be going back to table 4.1.5.3 to see what that says. Basically what that's saying is that these serve residential floors where they have a uniform live load. So a uniform live load simply means they don't have a concentrated weight in one area. It's pretty much spread out evenly throughout the floor. And the other note is saying that see sentence 9.23.9.4 for alternatives to strapping. So you can have some alternative to strapping, and if you want to know what that is, you can look at that sentence on 9.23.9.4. So for the purposes of your assignments, we're going to be using the second page of table A1. We're not going to use the first page. We don't get into Douglas fir around here or hemlock fir, and we'll be using the spruce pine fir. So that section of the table is what we'll be using. Also, as we work through our next example, have your Ontario Building Code out and for the purposes of clarity, and you can reference to it. So let's say I had a floor where my span was 15 feet. So my joists are running this way, and the span from the interior of both supporting members, my foundation walls, is 15 feet. That's my clear span. So the first thing I'm going to do is convert that 15 feet into meters. And the conversion rate is 1 meter equals 3.281 feet. So I'm going to take that 15 feet, divide it by 3.281, and that's going to give me 4.57 meters. The next thing we're determining is the size of lumber. So we're going to use number 1 and number 2 grade lumber, and let's say that we want to go with a 2 by 10, which is a 38 by 235. The road that I'm going to be looking at is right there, at 38 by 235. Now the only number in that row that's bigger than 4.57 meters is right there, 4.6 meters. We can't undersize a joist or the span for our joist. It has to be above or equal to. So the only joist that would work would be 300 millimeters on center, which is 1 foot or 12 inches on center. It would have strapping and bridging, and it would be a 2 by 10 or a 38 by 235 floor joist. Another way to word that question would be like this. Given a span of 3.2 meters, SPF number 1 and number 2 lumber, and a floor system using only bridging, what size of floor joist and what spacing is required? So the steps for this question would be to determine what we know. We know that it's an SPF floor joist system, so we're going to use the SPF commercial designation. We know it's number 1 and number 2. So we know it's in this area in the middle there. And we know that it is a system using bridging only. So that is right here. Bridging. So we know it's going to be in this area that's highlighted in pink right there. So we've narrowed down the columns and the numbers that we need to look at. The other information that I have is that the span is 3.20 meters. So when I select my joist space or my joist size, I want to use the number that is the closest to 3.20 meters without being under that number. So the maximum span is going to be the closest to 3.20 meters. So if I look at this chart, I could select 3.81, 3.58, and 3.27. Now the most correct joist size and space to select would be a 38 by 184 at 600 millimeters on center. So that is a 2 by 8 at 2 feet on center. The other ones here would be okay to select as well. The only problem with selecting the other ones is that you're actually putting more lumber that's required, so it's going to cost more. So if you're bidding this job, you might not get the job. It's definitely going to be stronger, but it's definitely going to cost more. So the most correct is the answer that's structurally okay and as well as the most economical. That concludes the floor joist span and spacing tables. Please complete the practice assignment that follows this video on the learning management system. Thank you.